Alright guys, my name is Mike. I'm with A.O. Reed. I did the startup and commissioning on top of, at the Cal Poly Pomona project. We are on building D roof. We're on the water heater side of the building. We're going to be doing the condensing water heater training today. We have Troy with DV Sales who did the commissioning and startup of the units. He'll be giving you the overview on the system. We'll talk about the two water heaters and the circulation pumps and the interfaces with the circulation pumps. Yesterday we briefly talked about the pumps and what they're serving. Troy will go into the function of the button and controls in that way. We'll also be talking about the storage tank today as well. And then we'll venture on to the other building roof and talk about the condensing water heaters and then the VFDs. All right? Here's Troy.
I'm Troy, DV Sales and Service. This is a Mach 400,000 BTU water heater. Just gonna go over the basics real quick. We got our main power disconnect right here. We got a switch inside. Be careful. Gotta get in here. The regular flathead. Open it up. Got a main panel. So, it's kind of hard to read. Right now we're just in standby mode. We're at temp. The water heaters are set for 140. Trying to maintain 140 degrees in the tank. It will fluctuate at the water heater side to about 5 to 8 degrees above 140. And to adjust set point if you need to, you hit the M for menu, go down to settings, click OK. First one up is the set point. You click OK again, the actual number starts blinking. You adjust as needed, click OK again. It sets the set point.
We need a minimum of 140 though, okay? You can't go under 140 because we have a storage tank for water. If you go under 140, you could have the potential of growing Legionella, okay? Make sure we keep the set point at least 140. It should be kept at 140 all the time.
If you do have any issues, the code will come up on the display. There's two different kind of faults. There's an A followed by a set of numbers. That's the lockout error codes, which have to be reset. To reset, you push the I button, and that'll reset the unit. And then there's a set of codes, the blocking error codes, which are E followed by a set of numbers, and those will automatically reset once the issue is fixed. And then there's a whole troubleshooting guide in here. So we got the A's here, E's on this side.
What's the difference between the A's and the B's?
Or E. What is it? One is just able to be reset, and the other one is not. So it's basically like low gas pressure. There's a gas switch inside, so if it notices that, it'll go into the blocking error code first. Which, I think like after 20 attempts, if it's still at low gas pressure, it'll go into the lockout error, where it has to be reset manually. So we got our pressure relief valve here, right into the drain. We got our main gas shutoff valve here. If you ever have to do any work, cut this down. We got our cold water side, feeding the water heater here. We got an isolation valve here. Hot water out to the tank here. Here, got our isolation valve here as well. That leads into the pumps. And as far as maintenance on these guys go, it's pretty basic. It says every year check water piping, make sure there's no leaks. Check the relief valve every year. And every 3 months, check the powered anode system, which is this little light right here. Green means good, red is bad. It's really hard to see, but green is actually on right now. Every 6 months, it says to flush the tank. So you'll have to isolate and then use a drain here, get a hose, go there, drain it down, then refill it back up. Make sure you shut down power before you isolate. and drain. Check the condensing trap every 6 months, which are over here. Down here on the ground. So these are the neutralizer kits. You want to make sure if it's clogged, you don't see any water draining out here while the units are running. You know, something. There will be a blocking issue on this if that happens.
Also?
Yeah.
So those are for the acid, right?
Right.
So what's the maintenance on those?
Here it says every 6 months to check it. I would say it's kind of case by case situation. Check it. If it looks really black and dirty inside there, then yeah, you want to replace the pellets. I would say for sure replace the pellets every year. For sure every year. And then it also says to check the combustion system every year as well. So
these have induction fan motors?
right. Yeah. So for part of my startup, I had to check the exhaust, and there's certain levels that the manufacturer recommends. So my company does offer annual services, and that's one of the things we'll do. We'll check the combustion, make sure everything's right there. We'll replace the igniters, the flame rods, check the circuitry on the blower, make sure, pull the burner, clean out the burner, clean inside, and do all that stuff.
And everything's up there.
Yes, sir. This white lip part slides right off, and then you got your gas valve blower right there on top.
Shit. Can get past this.
No. It's not this whole part. It's just the lip.
Oh, the lip.
It sits inside. There's only like an inch.
Overhangs the edge of the cylinder here.
Right.
That
So-
whole cover comes off. And then all this parts are in the top there.
All right. So I guess let's get back over here into the pumps. These are wheel pumps. We're manufacturer rep of those as well. So basically what this is doing is pulling hot water from the water heaters into the storage tank and circulating that way. So we're keeping 140 degrees in the tank. We have two aquastats right there in the box in the front of the tank, which are controlling these pumps. So if we're at 140 or above in the tank, the pumps will shut down. If we're below, we'll turn on, circulate the water to fire up the water heaters. Right now, we have these set. We're at temperature, so they're off, but they run at 3,700 RPMs to circulate water through. The good thing about these pumps is they're maintenance-free. They're self-lubricated by the system fluids, so you don't really have to do a whole lot. Just check for leaks or anything like that. But yeah, again, we have isolation valves here and here. We got main power disconnects here, just switches. So when draining, these make sure the corresponding pump is turned off first, and then isolate, and then drain. You don't want to isolate these pumps running because it can deadhead and damage the pumps. That's about that. Any questions so far? Pretty basic stuff. Pretty straightforward. And then I guess I'll hand you off to Mike so we can talk about the tank a little bit.
You guys have any questions on the two water heaters? Water heaters are standalone, they're not linked together, okay? So they operate independent of each other.
Okay.
Any questions on the water heaters? There is a filter, right? An air filter? No, it's just straight through here. No, yeah, you got the first screen on.
Right.
Yeah. Since we're up on this side of the roof, we'll jump into the storage tank here. Talked about it yesterday a little bit. To follow up on some maintenance procedures on this, the manufacturer recommends monthly that you We check the pressure off the tank and make sure we're not over the manufacturer's recommended maximum pressure. Inside this cover right here is the manufacturer's nameplate. So to get that information, you can go in here. That's also where the aquastats are. There's two aquastats stacked on top of each other. Remember, the aquastats are controlling each individual pump. One aquastat for one water heater, one aquastat for the other, okay? Yesterday we saw the aquastats, and examples are over here on the circulation pumps. So monthly, we also want to open the drain on the bottom of the tank. Down at the bottom of the tank here, we have an 1.5-inch valve. Right now, there's just an 1.5-inch plug at the bottom of it. What we'll want to do is, I'd recommend putting like an 1.5-inch straight nipple. So it's an 1.5-inch nipple by at least like 12 inches or so will fit in here, and then reduce down. So if there's any debris or any sediment in the tank itself, you'll have a full size height to blow it down into, and then reduce it in case there is debris. If you put a reducer right in the valve and you open it and the debris is enough that it can build up when you try to shut the valve, you'll have a problem, okay? You won't be able to shut the valve back off. That's why I recommend putting at least like a 12-inch nipple, and then you can put like a 90 and then reduce after that, okay? Because if you do your blow down and it builds up that 90 and you shut the valve and it won't drain out, at least you can unthread that and then clean out that fitting, okay? Does that make sense? On a tank like this, it has a bigger valve than like a normal 3/4 garden hose size, okay? This is a cement line tank, so the manufacturer does not require anode rods for the tank, so you don't need to worry about doing anything of that. It is an optional device that you can install down the road if you guys deem that's necessary, okay? And if the tank is fitted with a pressure relief, they want you to monthly gently lift the pressure relief and then gently let the pressure relief come back down and seat itself as a monthly inspection.
What's the recommended period on the lining on that tank?
The lining is to inspect yearly.
Relining it.
Relining it. I don't have that right now. I didn't see anything today about.
It's usually 5 to 10 years.
Okay, yeah. We'll have to look deeper into the thing. I didn't see anything in the maintenance section about when that would be relined, but it is a cement-based liner, which will need to be cleaned. That's an annual cleaning. You'll open up the manway, and there's a procedure on opening the manway in the O&M manual under section C. They give you the procedure on how to open it. Just make sure anytime you open any piece of equipment that might have an O-ring, that you're looking at that equipment first and you're ordering like a rebuild kit, like a gasket rebuild kit, because sometimes the gaskets can't rip when you open up a device. It'd be better to have that replacement kit on site versus opening it, finding out you rip a gasket and now you can't put something back together. Mostly important on like the strainers we talked about yesterday and any type of that equipment, okay? Yeah, just check back in with the actual maintenance O&M for the type of cleaning procedure, but that cleaning of this tank right here will be an annual process. Obviously, when you're draining the tank, at that point, you're going to need to make sure you schedule that. There's no bypass around the tank to provide hot water for the building, okay? So know that when you're doing that inspection, you're not going to have the hot water to the building, okay?
It'll be in December time.
That's what I was going to say. Yeah, like a holiday, like a Christmas holiday or something like that, right?
Well, we do it through the semester breaks.
Yeah.
When they shut down, usually everybody shut down.
Do they shut down dining buildings too? Okay. That's all I got on the storage tanks. We're over here right now. We're doing VFD training too. If you guys don't mind, I'd like to talk about there's only one VFD up here on the exhaust system, okay? There's no questions on any of the other water heater stuff? Okay. Reed. We're up on the water heater side of Building D roof right now. On the fan systems that are on Building D roofs, either side, there's only one piece of equipment, EF1D, that has a VFD on it. So to tune the amount of exhaust they needed for the hood downstairs that this fan serves, they chose a VFD so we can change the operating speed, okay? That's already been logged into the unit. The most important part of this unit right here is that the functions down here, are you guys all familiar with ABB drives at all? Semi? So this is the ABB, this is the drive keypad, and this is a bypass keypad interface. We are never using the bypass interface up here, okay? It's an extra feature. I tried disabling it, but it always throws an alarm code, so I left it on, but just know that we always want this light over here to be in drive. This is a green light right here. We want to be in drive mode. We don't ever want this light over bypass to be green, okay? We're not ever operating in bypass mode. So we have a green light for drive. We're choosing drive. We have a green light here. The system's enabled. The motor run light is off because the fan's not running, okay? We want to be in drive. We want to see green lights. If you see a green light here, the fan would be running. Done with this keypad, we're moving up to the drive keypad. The most important thing is that when you guys come up here, that you do an inspection on the keypad, and we want to make sure that this unit always stays in auto. In the top left corner, you can see it says auto. That's going to be able to turn this fan on and off, okay? This fan is only being turned on and off through the Ansel system, okay? So if you came up here and press hand, the fan will run for an indefinite amount of time, okay? We want it to be in the auto mode. The VFD's already been set up for the motor horsepower, the amperage, the voltage, and the RPM of the motor. The fan will ramp up and ramp down. This system right here is pretty basic. It's just an easy starter that allowed us to lock in a certain speed for the fan to run.
What determined the speed?
Our balance guys that we hired calculated the CFM, or the engineers calculated the CFM. The balance guys took all those readings and measured all the readings downstairs at the hoods and determined what speed this unit needs to run to give us those CFMs at the hood.
Okay, so there's nothing, there's no control, there's no sensor controlling it.
There's a temperature sensor, I believe, in the Ansel system, that if the temperature in this ductwork over that hood rises to a certain predetermined temperature, it will turn on the fan to maintain that temperature. The Ansel system was provided by the electricians, and they should be able to give you the better on-off points on that. But this fan is being turned on and off through a start-stop command through the Ansel system, okay? I believe it was 47 hertz. Again, you shouldn't need to change any parameters in here. They're already here. This thing should be locked in. We'll go back to this is the main menu here. There's nothing under this button over here, so this button won't do anything. Menu is on the right. We press menu, we get into parameters. And there's different sub-menus at the beginning. It'll be like an 01, and when you click into 01, you'll see a sub-menu like a 01-01 or something like that. It'll be a sub-menu that you go down. All this has already been programmed. If you ever wanted to see the speed of the motor, you could use the 01, it's operating data. The 03 is setting up fault signals. In 04, you can see fault history. The start, stop, all that, none of that stuff should need to be changed. It's already, we're just using the factory start, stop setting on here. So the BMS control system does nothing with this fan. I think they're only monitoring light current if the fan is running or not. So you'd see status on the front end if it's running, that's it. But they don't have any comms, they're not turning on and off this unit. The only way this fan right here is being turned on and off is through the Ansel system. Okay, through this VFD. I was trying to... It's exhaust air, so it's sucking air out of the building, out of the kitchen hood area.
It's coincided with
I
the
believe
hood,
this
right?
was off of the grill, if I'm not mistaken.
Yeah, so it's coincided with the hood.
Yes.
The hood on downstairs is running, or just close it out to this way here.
Actually, this isn't the grill. I got to double check for our training for tomorrow exactly which unit this is serving,
Okay.
EF1D.
And this is automatic reset. If the Ansel system goes off, if the fire alarm goes off, it's reset. This automatically resets to come back on.
If the Ansel system tells this fan to turn on, it will turn on. If the Ansel system tells it to turn off, it'll turn off.
So is there a manual turn?
As long as we're in auto.
Right.
This keypad has to be in auto. Sorry, guys.
Is there on and off switch downstairs for this? Other than turning on the grill?
Talk to the electricians that provided the Ansel system, provided the switches. Like, some had them and some can't. I don't remember which ones are which at this point, okay? So I wanted to just tell you this thing will be running at 43 hertz. 43 hertz is the set point on this fan. So when it turns on, it ramps up to 43 hertz, okay?
That's maximum speed, though, right?
That's the, when it turns on, it goes to 43. 43 is the set point. It doesn't modulate, it only operates at 43 hertz. This fan's been balanced downstairs to give us the proper CFM. The fan is oversized, so we don't need to run it to 60 hertz. At 43 hertz, we get proper CFM down through the hoods.
If your CFMs aren't required, that's our CFMs aren't required downstairs. It'll modulate to compensate, right?
It's a constant volume hood, so there's no changing devices down there. The only way it can change is if the grease traps start building up with grease. You'll start lowering your CFM through the hood, but at that point you need to clean the grease traps, not speed up the fan. Does that make sense?
Yeah.
At 40,
the reason why you got a VFD on it is so you can vary your frequency drop.
that or just so instead of, if it just had a starter like you'll see tomorrow, a lot of the other fans just have starters. You go and run it at 60 hertz.
Right.
If we don't need it at 60 hertz, having this VFD, they knew that the airflow might be able to change. That we can change that airflow depending on the CFM we need. But it's not a modulating system. It's locked in at 43 hertz per the balance. Does that make sense?
Yeah,
I know what
makes
you're
sense,
saying.
but it's a little bit overkill is what I'm thinking, because if you're going to run it at a certain speed,
You're saving
Sorry,
energy
you're
by
balanced.
running it at the drive at a lower speed.
They could have balanced it.
yeah, I understand. It's just that the reason for the frequency drive is to vary your speed on it, so you can.
It's an option.
If you got more airflow down here than you need, then you have great spins here. If not, it slows it down.
So it's a constant volume system though.
Right, but it's not.
Instruments reading it. Oh, that's it.
It's not checking your.
We're not maintaining any static pressures.
Right.
Yep.
Okay.
Nope. It's just we have the drive here, so during the balancing procedure, we have the option to slow it down and lock in a speed to adjust the speed in that way. Okay. Just that's how this one is operated.
Okay.
It's the only VFD on an exhaust fan on this building.
Oh, okay.
Okay. Just wanted to make sure all that makes sense to everyone. At the top display, we have percent speed. That will be out of the maximum. The percent speed that'll run out of 60 hertz. So it'll always be the same number. And then it gives you an amp readout. And then this lower display right here is currently volts DC. We're not using an external speed signal, so that will always be 0. In the future, if you guys see that you want a different readout, it can be changed in the display parameters, which is 34.
Is this you know if this is tied in with the HVAC controller so we can see it on the computer?
Like I said, the only thing you'd see here is status that the fan is running.
Okay.
Okay. But as far as like being able to turn it on and off through BMS, no.
All right. Well, I just wonder if it had anything in there that would say that yeah, it's got pressure in there or it doesn't, so we could verify that it's running.
Just status, a status current sensing donut is the only thing that I was aware of.
Oh, okay. So it's a sensor on the right.
Yeah.
So if we get current flowing through it, it'll say that it's on or off.
Yep.
Right? It's not a contact with space.
It's not a contact switch.
All right.
It is a belt-driven unit, but we'll go over that tomorrow. For this fan, the most important thing is that we remain in auto. If we're not in auto, it can't turn on that hood downstairs, okay? That's all I got on this for this VFD. Again, we're not using the bypass. Okay? We'll make it over to the other roof.
Like I said, these pumps are the same as these pumps. There's only a couple minor differences. These two are master slave, and these two are master slave. This runs standalone. They're all run off these aquastats over here for the temperatures. So these two, got this one is the master, this one's a slave. You can see on this display it says SL. That's a slave. This button does nothing. Can't do anything with it. They just made temp, so this one's now off. Okay. So, can't really go home. Okay, we can see up here. have to change these speeds at all. We're set at 3,700 RPMs right now. All you gotta do is spin the dial, and then get to the desired speed, click the dial in, sets it. Can you turn on one of the actually? This one's actually set at 25. So these two are connected together, right? So on this one, you can see there's a little black bar at the bottom. That means this one's online. It's running. It's kind of hard to see. It's like you can see like the pump head, and there's a black bar in the middle. So up here, this one that's off, it's just got the pump head, no black bar. These are set to rotate operation every 24 hours of runtime. So only one of these pumps is going to be running at a time. Same with these ones. This one's going to be running almost continuously, just because it's standalone. These two we got are the 140 return. These three are the 120 returns.
Remember the upper ones, the non-kitchen. We have kitchen return and then the kitchen 140.
So basically, these pumps are the same as those pumps over there.
Yes, sir.
And they're configured the same. They all just might be at different speeds.
And
I'm
we got
looking for spare parts.
power disconnects here. Go to the corresponding pumps.
If we have an issue with one of those pumps and it goes down, is there a way to make the other one?
Yeah, if one goes down, it'll automatically switch over. Yes. Now this one it won't. It'll just come up with an error code, and you have to contact us.
Are we able to look at these from the EMS system?
Those now.
No? Okay.
Extra. Can be done, but extra.
Well, I don't know how far they went. They could do everything.
Yeah. Same with the water heaters. They are not connected to the BMS either, so you have to visually come and check those out.
Oh, we'll talk about that later. We're going to try and make it so we're going to have to come up here. Just look on the screen, tell me what's going on.
I agree. So yeah, currently I'm not aware of any, but double check with Doug. He's the Sunbelt controls guy. I don't believe there's any temperature monitoring sensors up here to the BMS.
Well, that's what I say. We'll have to check with Kevin and guys, state guys, to see what we can do to maybe get something up there, monitor temperatures. I mean, the system's capable of doing it. So if we have to spend a little extra later on to make it so it's easier on us. So if they have a problem in the kitchen, I can tell you, okay, I got to pump down, or it sends them an
Well, you
alarm.
can see it before they call you almost.
True. That way when they call, like, yeah, we know about it.
Any questions on the return system?
You got
Mixing valves going out to the system.
Yeah, so those are the mixing valves. That's the water coming back in the mixing valve. I'm going to try to switch out those ball valves for circuit setters.
Okay.
So we can make adjustments. They don't need to be. I'm going to try to do that. That was part of our training yesterday, but just real quick, the circ pump is pumping water back through the mixing valve and out to the system. So this is the low temperature return right here. Make sure I'm showing you the right one. So that's going to be off of our non-kitchen return pump. So what we do is we pump just a little bit of the water through the high temperature loop, which is through the tank, and then that will blend through together and give us a good 120 leading set point during no use demand. Okay. While there's demand and usage, it'll just flow through. The regulator itself will modulate to mix the hot and cold and go out as 120. But no flow. Make sure when they turn on the sink and it's 120, it's running through this line right here. So we were saying if something weird happened in the system and the sink changes, if the temperature goes up, you can open this valve more. If the temperature is down, then you want to close this more and let more water go through the 147. But they have been balanced right now where they're at, both systems. What do we got? 119. Yeah. 118.9 or something. Okay. All right, let's go to the other roof. No questions? Okay. All right, guys. Mike again with A.O. Reed. We're on Building D roof. We're on the boiler side of the roof. We have Troy here. He's from DB Sales. He did the training on the Bach water heaters. DB Sales also was the provider of these RBI heaters and are the factory service reps for them. So Troy's gonna give us the training on the boilers.
All right, first off, we got our outdoor cover kit here. Careful, it gets really hot in the sun. A little screw here, you gotta screw it, lift this off. We've got our main display here. Sorry, 1 second. No. Alright, so these are going to be, I believe, BMS controlled. This is the master boiler. These are the two slaves. Right now we have a 150 degree set point on there. I believe you'll be able to control that through the BMS, the set point. If anything should happen to the BMS communication to these boilers, the boilers will switch over from remote mode to local mode, and they'll run at their own set point, which they all have their individual set point set. So we got inside here, we got our fan VFD, which is not running right now, we're at load. We got our Honeywell burner control. So if you have any flame failures, pilot flame failures, this alarm light is gonna turn on red. You'll also see a ignition control alarm on this front panel here. So you hit the reset button, resets. If it continues to fault in the same issue, then you want to contact us to come out and take a look at it. So that's our first safety. We also got the main power disconnects here. 1, 2, and 3. Open up these panels for you. So we got our pump, 3-way valve. Oh, actually sounds like it's starting to fire up. So you're seeing it's trying to start now, but I've just shut off the gas, so it'll go into alarm. We got our Dunn's gas valve here. No pilot, but not going to main flame. This is our pilot gas valve here. Here it's going into alarm, right?
Yeah.
What does that say on the front display?
Phone, system, and ignition control.
Ignition control alarm, exactly. All right, let me show you. Kind of don't really recommend it, but if you're up here doing anything and this beeping's really bugging you, you hold back and select at the same time, shuts the beeping off. The alarm is still present, so we'll reset that in a minute. I just want to show you a few things in here. I'm gonna have to show you on the far side too in a minute. So back here we got the air filter. That's gonna be your biggest maintenance issue, not issue, but thing you need to.
Right,
yes. You'll be able to take it out. Alright, so you can visually inspect from the other side and this back side.
Yeah.
But to get it out, yes, this top panel slides up, slides up and off.
How does it come off? Is it screwed in or?
No, you just lift up.
okay.
There's just like a foam gasket up there.
All right.
And you got to be careful when putting it back on. Mess up that gasket. But yeah, you want to make sure that filter's clean. If it gets too dirty, and air's not getting through, that means dust and dirt is getting into this blower, down into the burner. If that burner gets clogged up, it's going to break, cause a lot of issues. So I would recommend checking that at first, every couple months, and then kind of get a game plan on how these react, because I mean you're outdoors, right? So it's going to be pulling. It's kind of covered here, so that's nice. Hopefully not as much dust and dirt will get in, but you want to know your units. So I would say check it every couple months, and then definitely replace the filter every year. depending on how dirty it gets, maybe every 6 months. You can, like we showed you, pull this out, pull it out, and you can blow it down with compressed air. It's very simple. I believe these have arrows, directional arrows on the filter, so just blow with the arrows.
There's a fire, right?
Yep. UV scanner.
Where the burners at? in this thing?
The burner is right down in here, yeah. It sits right under this blower mount. Actually, this is a blower mount. This is just the tubing. Right below this is where the burner is. And again, my company, we do annual maintenance on these all the time. So we completely open it up, clean everything out, replace filter, gaskets, igniters. We check the operation of the UV scanner, check the operation of the pilot, take pilot pressures. We do combustion analysis again on these, make sure it's in the right running order. So we got that. So like you see, we got gas valve here, right? You got shut off here. This is the pilot line, pilot shut off valve. We got a couple pressure relief valves in here, one on each side. Alright, so I'm going to open these back up.
Pipe to drains.
Yes, they are pipe to drain. Very nice. Alright, so go ahead and open that up for me. Put this back on. And hit that reset that I showed you before.
On the burner control?
Yes, sir. Recycled it. Okay, right. So if you guys follow me back here real quick, there's going to be a low water cutoff installed here pretty soon. Yeah, secondary low water cutoff. It's going to go right over this probe here.
It'll be a gray waterproof junction box.
Right. Under that, it's going to be a black box, and on top it has a reset button. You just hold the reset button and it will reset to low water.
So if it trips on low water, yeah, you'll have to, if you shut the valves and drain the system, you'll have to actually reset that low water. There's also a test button on it as well. And you can hold the test button down and it'll put the unit in to low water condition.
So
We're just waiting for waterproof boxes.
So this three-way valve
Yes, sir.
between the in and the out.
Yes, sir.
What's its purpose?
It's to preheat the water going into the water heater or to the boiler to make it above condensing temperature.
So if this opens, it closes based on temperature. So if it's cold, it just
The water
keep it within the boiler.
The water coming on the inlet is too cold. It'll pull from the outlet to warm that water up so it doesn't condense.
All right. So it's already self-contained.
Yep.
No adjustment on that.
Correct.
It's an OEM product. We got the parts. You guys sell the parts, right?
Yes, sir. Yeah, we sell everything for these boilers, as well as a box.
Oh,
and
it's a card.
What's that?
All we need is a card.
The card? Okay, I got the card for you. I like the dunks just because they're very easy to work on.
Very easy to work on.
These for adjustments, just here and here, super easy to do.
Jeremy,
Don't touch that, please.
Right.
They are at a specified level already. And then we got our isolation valves here on the water side. And then I think the other one's going to be on the outlets, right over on the other side.
You're on the outlet.
No, this is right. Yeah. And the inlet.
It's down here in front of the unit.
these are for the heating.
We went over the valves yesterday, the shut-off valves on the units. Yeah, the lower pipe is the inlet. It has a strainer.
You need to adjust both set points.
So you said they're 140?
This one's set at 150 at the moment.
150?
Yeah.
Wow. It's kind of low, isn't it?
Okay, so we're on, I don't know if you can get in here and see this. It says running at 57% right now. So it's modulating down. And then it says system set. That's the 150 is our set point. So all you got to do is hit select. It starts blinking. And then you adjust up or down. And then hit select again to set the set point. It's very simple. The BMS is not controlling this at the moment. When it does, everything will be switched over into remote mode, and they'll all talk to each other and work together.
Is that red light indicating a flame or a failure?
This one is on flame,
Okay.
and it's a main flame, since the yellow one's lit up as well. That flame will be on as well when the pilot turns on. It's just the UV scanner is picking up a flame.
Okay. I just usually when you get red, that's an
Right,
indication it's going to
right.
fall.
Yeah, so you just got to
So
worry
that's
about the very bottom.
Yeah, they're
Right.
indicating as hot.
Right. Yep. There's flame inside. This here is our high water or high limit, high temperature limit. So you have to take that little red cap off and try not to lose it like I did. And then there's a little reset switch right here. You lift it up and it resets the unit as long as the temperature inside is below the set point on here, which is
That's for high temp.
set at 235, 240.
That's high limit.
Yeah, that's a high limit.
Yeah. Oh, take a bit of 150 back on it in case it's too low. Our building holders
So there is
Also, too, we're going to be able to shut
boiler
show
power
what we
switches here on the front of the displays. That just shuts the power or turns the unit off. Basically, there's still power to it. So you got disconnects to shut the power off completely. So yeah. Other than that, any questions on these?
You talk about the heat
How
exchanger.
much is the warranty on this?
What's that?
How much is the warranty?
I didn't hear you. I'm
How
sorry.
much is the warranty?
How long is it? What?
The warranty.
The warranty? I'm not sure. I think
That's the warranty will be through AREAD or AVAD contracting. It'll be a 1-year warranty from turnover. I think they're still waiting on that date. You tell them that there's a vent on the three-way valve.
Oh, right. There's a vent here.
So if you guys drain down the unit, make sure it's a manual vent. You gotta open it, twist it open. And then just tell them about the heat exchanger.
I don't know. What do you want on that?
Do you want me to open that panel down there? No, we don't need to open the other panel.
Right, no. Yeah, because it doesn't. I thought it would slide out. It's got to go
from
up
the
to the
top.
top. So yeah, if you're gonna open this up, I almost recommend having 2 guys to do it. It's a little heavy. It's just more awkward than anything, especially with these steps. So what we usually like to do is open it up from the back side and slide it down to the front. And then same thing when putting it back on. Have it angled up on the front, slide it all the way to the front, top, and then angle it down. That's the best way to kind of handle that.
So yesterday we didn't really talk about the piping system for the boilers. Since these boilers all have internal pumps, this is a primary secondary loop. The pump is pulling water out of our secondary loop that goes out to the building. So we have an air separator. The water's coming back on the upper pipe back here. Comes around the horn. It makes a turn here. As long as the boiler's not running, it makes the turn here. And it makes a turn and it goes back into the pump and it goes back out to the system and then it comes back up that top pipe again, okay? We create a primary secondary here. This is a decoupler line in between the 2 pipes. So that allows the flow for the building pumps to pump water out to the building. But then it also allows water to get sucked out of that pipe drawn through the boilers when a pump is running, and then it gets pushed back through this pipe and mixes in the water as it goes back into the main pumps. That's your primary, secondary, okay? The building pumps can't push water through the water heaters. The distance between the two pipes doesn't create a big enough pressure drop to be able to push the water through there, okay? Does everybody get that concept? Do you guys have primary, secondaries anywhere else?
No.
Okay, this is primary, secondary up here. Just for your brain, building A and B are variable primaries. All the water is going through the at least one boiler at all times. Okay, primary, secondary here. Like you mentioned too, like Troy mentioned, when you're fully in command of all the switches inside at the bottom of the unit, and they all need to be in remote mode. And then these are linked together, right? There's a master and then the two slaves. And the BMS, the master is this first one. The BMS guys just enable the system, and then the master will do all the staging of the other units. If you have to do maintenance on the master is also getting its temperature from that sensor right up there.
Header sensor.
The header sensor.
It's a good point. If this has to be shut down for any reason, power turned off, you have to put the other two into local mode. They're not going to be receiving a signal from the master if the power's off.
So no matter what, so if you lose power to this first one, so if you come up here on a call that they don't have hot water, then obviously you're going to need to figure out if this is off. Then we'll need to open up those other two panels and then switch both of them into local mode, and then they'll just internally work off of their own temperature.
Yeah, they'll work off its inlet temperature.
Okay.
But if this one goes into fault, there's a flame failure and it's not running, these two will still run off of this command.
Okay.
So you don't have to worry about that.
Only if you lose power, if the power gets turned off.
Right. And I believe if this loses the BMS communication, then they'll automatically switch over to local mode on here, which will still control these two boilers at this local set point. So just if you lose any power to this, then these two aren't going to run unless you put them into local.
You guys good with the boilers?
That'll be in the IOM manual. There's a list of troubleshooting guides in there, like there's just follow the rest. And I'll give you the definition or explanation of what's coming up on the display, and find out your possible causes and remedies. And try and keep these on at all times, unless you're doing any work or checking. Because I mean, it's the outdoor cover kit. You don't want any moisture or dust or dirt getting into here. So
And the UV light will probably wreck that screen too. You won't be able to see the display.
correct. So we got this lip here. We want this to go around the back side of it. And there's a little screw here. It's kind of a pain to find the bolt inside. Screw it on tight.
Good? We'll move into the rest of the VFD training for over here.
Up here?
Yep. Make sure. Just put the panel on. Okay. It's not going to be till 3 though.
What's that?
I'm rolling there.
All right, guys, we'll come right down here. I'll get these first two going.
Yeah.
All right, guys, we're rolling into VFD training. We have 4 pumps. We're up on the roof of building D still on the heating hot water side. Okay, right now we're looking at the 2 chilled water pumps. We have chilled water pump 1D for dining and then 2D for dining chilled water pumps. They're the 2 green pumps right next to us encased in the boxes. Okay. We have NEMA 3R enclosures. On this side over here, we have the bypass. This is what I was talking to you guys about on the other side at the exhaust fan. So again, in this pumping application, we don't want to use the bypass unless absolutely necessary, okay? Because the bypass is going to run the pump at full speed, 60 hertz. So if all the air handler valves and the chilled water valves downstairs are closed, you're running this pump at full speed and it's going to kind of deadhead the pump, okay? So only in a major emergency, if you lost both drives on both pumps, should you try to run the bypasses on either one of the pumps, okay? And that's controlled by these buttons over here. Just like over there, we got our, so this is called an Eclipse bypass interface. On the left side over here, it says drive. We have a green light, so we're in drive mode. On the right over here, it's bypass mode. There's no light on, so we're not in bypass mode. This is how you would turn it on and off in bypass mode or be in auto. Again, we don't want to use these unless you had a multiple drive failure, okay? And even then, you got to be careful using the bypass, okay? What you could do is if you did have to use the bypass, if you tried to throttle down the outlet shutoff valve to maintain like a certain amount of flow, you could probably do that. Build up a little bit of more resistance with the butterfly valves that are here instead of the control valves down in the building. Okay? So again, back over here, just so you can see the internal, all the controls are done on the bypass, even though we're not using it. How this is configured, it's configured for the Eclipse bypass. So the main brain of this apparatus is in the bypass. So the start stop and all the enable from BMS is going to be done, terminated on the bypass board. And then just the analog input signal is going to be over here. That's the speed reference signal on how fast the drive should be running. Okay, that's the only thing that gets landed on a drive with the Eclipse bypass. Everything else runs through this communication cable, which is Modbus, from the Eclipse bypass to the drive. There are fans in here. We have a couple cooling fans, so those need to be checked. I don't believe there's any filters on this unit. We do have a heater assembly up here though, so the heater will help. There's a strip, you can't really see it. Let's see if I can pointer to it. There's a heater strip right over here that's going to help maintain temperature in the drive compartment, so in the wintertime when it gets super cold out here, we don't have condensation all over the outside of the unit. Okay, and this is the heater assembly controller right up here. This is the main disconnect down here. So right now I've turned it off. There's still power underneath here. We're not breaking the plane of the compartment. After the disconnect switch, we have a couple of input fuses right here. And after that, the power switches off into the bypass or the drive mode. So when you choose bypass or drive, it'll pull in different sets of contactors, okay, to operate in drive or bypass mode. That's all behind this interface right here, the Eclipse bypass panel. Once a year, you want to shut off the power, but down at the main breaker, you'll want to shut off the power and check the tightness of lugs, and as needed, if there were a buildup of dust or material in here, you'd want to use dry nitrogen and blow that down. You can undo the fan connection up here, the communication link up here, and then there's 4 snap screws that this whole Eclipse bypass panel will come off. And that way you can get to the contactors behind it to check the tightness of all the lugs. As things heat up and cool down, especially being up here, things expanding, contracting can become loose, and a loose wire will create nothing but problems for a VFD. Okay. So this device over here is the actual drive itself. This is what adjusts the frequency that goes out to the motor. VFDs take AC input, they create DC power, and then on the output of the DC, they chop up that DC signal, and then that creates like a modified AC sine wave that then changes the speed of the motor. Okay. Communication cable right here to the keypad, so you can see it with the front door being closed. The BMS is monitoring current status here. That's all I got on this side. I'll close this guy back up. Power back up. VFDs have capacitors inside of them. So when we turn off power, we'll do it to this one so we don't cycle that one. You can watch when I turn off power, the display on the bypass will go out right away. The drive is where the capacitors are, see how it's still running. These drives aren't really big, so the capacitors aren't that big. They don't store their power as long. But just know the VFDs do store power in the capacitors. We want to make sure when we do isolate power, we give the drive a long enough time, the capacitors a long enough time to dissipate their charge, okay?
Oh, you ain't no fun.
All right. I just wanted to demonstrate when you do turn off power, there still is power, possible power in the drive, okay?
What is the voltages up here for?
We have 480 feeding
it's
all these
480.
pumps. 480, yep. Coming back over to this drive now that it's on and booted up.
Rookies.
Again, the most important part with these VFDs is that the keypads remain in auto. Our control guys are finishing up some integrations to these two pumps right here. So currently these were off, okay? But we want to make sure when we're doing our day-to-day inspections of the equipment that each one of these is in auto mode, okay? And that's in the upper left-hand corner. We'll see percent speed. Percent speed over here will be out of 60 hertz. Pumps are always run to 60 hertz. On the line below that, we have amperage. Right now it's off, so it's reading 0. And then below that, it's volts DC, which will be your speed reference signal that comes in on that analog input that I showed you was landed on the drive side of this over here. Okay? These screens can be adjusted. You can just, some people like to see hertz instead of percent speed. It's all user preference. Do you guys know how to change any of those settings by chance?
Not really.
No. Do you guys care to see percent speed or hertz? Are you guys looking at like normal? Are you used to seeing one way or the other?
What, would it show up on the PC that shows what it's doing?
It'd probably be both. It'd probably either. Depends what they're gonna pull in from the front end. I'm sure they can pull either point. It won't be this display. This is just the local display up here. So if you're walking up here, you want to see a hertz out of 60, or do you just want to see the percent speed?
So the hertz.
Hertz, okay. So what we do is we go into parameters. I press menu. We go up to 34. 34 is panel display. We select it. We got signal 1. So we don't want 1. 1's on the top, 2's on the bottom, and 3 will be the bottom one. So we go all the way down to signal 3. It's still an analog input signal coming from the drive. We go down to display form. It needs to be on direct. I totally messed that up. We want to change number 1. Sorry about that. So we need to get back into panel display. We're changing percent speed to hertz. Normally I change the very bottom one, which is in 4 to 20 milliamps, to 0 to 10, okay? So we're gonna start over. We're gonna go into panel display. Now we go. Signal 1 is the parameter, it's output frequency. So it still is an output frequency, we just wanna change the reading to hertz from percent speed. So we go to direct on 3404. And then instead of output unit is percent speed, we're gonna go to hertz. And then now when the unit's running, I'll just turn it on in hand right now, it should go to 20 hertz. Okay, and now it's scaled properly. So if we would have gone to auto too, since there's not a speed reference signal, it'll go to 20 hertz too, which is our minimum program speed, okay? So now that we made that change, we need to turn off the unit because we want to save these parameters. I pressed off, it's in ram down mode. With the style check valves we have, they're gravity check valves. We want to ramp the pump back down. If we just turned it off right away, it would slam the check valve down, okay? So we're ramping it down. So it closes the check nice and softly. So now we'll go back to the main menu, the main display. We press menu once. We go down to parameter backup. We go upload to panel. Have you guys familiar with this? When you make a change? So when I upload the parameters into the panel, I'm taking the information out of the drive, sucking it into the keypad, okay? It's copying. Now that all of our change parameters are stored in the keypad, if the drive ever goes bad, we can turn off power, we can switch the drive out. We take this keypad off. Well, you could leave the keypad on in this application. Normally, if the keypad was attached to the drive itself, you would take it off and put the new keypad on the new drive, right? This can stay there. What we want to do is, since I did make this change here, I can change it over here. The keypads are interchangeable. Since I have it in here, I have the program saved in here. I can change these keypads because the drive itself is already storing the data in it, right? Anytime you take off the keypad, if it's not in auto, you'll get a fault 10, which is a panel loss. We lost communication to the panel. We can just reset that. We know we took the keypad off, okay? So now what we want to do here, when it loaded, it took the data up into the keypad from the drive. So what we want to do is click on menu and go down to parameter backup, and we want to download the full set. We're downloading the information we saved in the keypad from over there into the drive. Now we read hertz, okay? So we transfer that instead of having to do changing programming. So when I downloaded that is what I was trying to show you guys. If you have to replace a drive, you could use the old keypad as long as the most current information is downloaded into it. Replace the drive and download that application into the new drive, okay? So now this one has the most current data. And then what we need to do in this keypad, because it came off of that one, is we need to upload the information into this keypad because we already know that this one was right. When I changed the signal number 3, I moved the decimal over too far. So I had a 0.00, so on our speed signal, it added an extra 0. I don't like that because it's only 1.1, 1.2, so we're gonna get rid of that. But now we made another change, we need to make sure we go back and upload that new change back up into the keypad, okay? For me, it's gonna be easier just to change it in here. So I just dropped one of the zeros out of the display form. And then since we made that change over here, we upload to the panel. This one should already be done. It says panel parameter upload successful. So if it says failure, obviously you'll want to reattempt that, okay? And now all the zeros match. Could have been an OCD thing, I don't know. It wouldn't have made a difference, it just looked weird. It didn't match all the other ones. Okay? So that's how you would change out, like if you had to change out the drive, you could download those parameters back into the new drive. And you're like, okay, good, all the parameters now are the same as the old configuration. The only thing you need to change, if the drive failed, you'd be fine with the communication because communication is done through the Eclipse bypass. Okay, so if I believe they're communicating Modbus to these, just pulling data from it, not controlling with it, okay? But you wouldn't need to do any new programming if it was just the drive that failed. If you had to replace the bypass, you would need to know the address. You need to first program it to Modbus, then know the address, and then the bits. I think that's probably beyond you guys. Are you guys controls too, or just, would that be Kevin?
Well, we talked to Kevin.
Okay, perfect. The most important thing about these again are auto and the keypad. It's not going to do anything right now. They're not sending it a speed reference. But until Doug is done integrating, I don't want to leave it in auto in case this thing, you know, goes to a setting we don't want it to right now. 2 VFDs, 1 per pump. A pump is redundant. Okay, we should only be running 1 pump at a time. Same with the heating hot water system. The drives are the same, exact same configuration. Those drives are actually just smaller than the chilled water pump drives. The programming, all the stuff I showed you on these two is going to be exactly the same on those up there. Questions on the drives? We always want to see the green light on drive and a green light up here enabled. If this was red, on a pump, we don't have any safeties like on a fan system where there'd be a pressure switch or something like that. So it's just a jumper wire right now for the enable. So that could be, if you see this red, somebody could cut the wire or it could have come loose off of the Eclipse bypass terminal. If you want to see green lights here, green light down here means the pump is actually running. And auto up here in the keypads. Anything else? Anything that was confusing on the drives? You guys all understand how they work? The bypass will do. If we turn on the bypass, full speed. The system might not like that.
Guess what's up?
Okay. When we do air handler training, I'll deal with the drives on those units because it's inside the air handler. And I want to talk to Doug before we open up the panel on that, just to make sure if we turn it off, it'll come back on. Okay? We'll do that tomorrow. Air handlers, fan coils, and exhaust fans. Okay? If there's anything else, I'll tell you tomorrow. Any other questions? Anything that I could try to look up if there's any questions that I don't know right now? Nothing? A lot of information?
Well, I'm sure there'll be questions down the line. For right now, I guess we're going to get a major understanding of it.
Is it like, what, do you not understand a certain part of it that I can help explain to you? Is it it doesn't necessarily have to be with the drive, it could be with anything. Make sure this door is closed too.
Yeah. All right, you got any questions, Raul?
On how the pipe system's piped or anything like that?
And again, all these videos are gonna become available for us, like, do a little bit, oh, you mentioned you talk about this.
Yeah, that's the.
Videos? Oh yeah.
Yep.
This is all for you guys.
All right, okay.
So I mentioned, right, the heating hot water system, primary, secondary, the chilled water just comes up, goes through the pumps or this bypass loop. Like right now it'll be the bypass loop. The pumps aren't running and it goes down in the building and back out. I showed you guys the main shutoff valves downstairs. So we know where those are coming up from the underground. That's all I got.
Miller tank.
Not for me. 2-hour drive home.
2 hours, Lancaster?
San Diego.
Oh, okay. Right.
Good, guys?
Yeah.
We're good.
Okay.
Thank you.
I mean, any questions on anything, even tomorrow? Tomorrow, if it's on anything that we talked about the first day, today, you can come up with any questions. I'll answer them. Okay? Cool, guys. Tomorrow's our last day
Okay.
for me
Yeah.
training.
We still got more.
Your heads will keep
you
getting
got a
bigger.
lot more.
Next week too. And
Oh yeah. All the electricals next week.
All right, cool,
All right.
guys.